Okay, on the extension question, so in this case, we are supposed to calculate the change in pH when this amount of moles of strong dibasic acid. So recall, strong dibasic acid basically means that there are 2 H plus per acid molecule. So when we add H plus, in this case, given that you have your weak acid, RCOH, and your conjugate base, RCOO minus, which is the species is going to react with the acid. Okay, think through. In this case, to remove the acid, you therefore need your conjugate base to remove the acid. So on adding H plus, your conjugate base now is the species responsible to remove the acid. Okay, so it accepts a proton and forms your RCOH. Okay, so let's check through the process of calculation. So amount of dibasic acid given 0.002 moles of dibasic acid. Since dibasic acid contributes to H plus, the amount of H plus added will be 0.00400 moles times 2, right? Okay, so dibasic acid, you need to times 2 to the acid to get the number of moles of H plus. So we can apply what we did just now. Okay, there's some alignment issues, so just let me draw the lines first. Okay, so initial, we have given the same context, right? 0.120 moles of conjugate base and 0.0600 moles of acid. Okay, so color coded for your easy reference here. Acid, base. So your base, acid. Okay, the H plus added in is 0.0400 moles. So we need to remove the H plus, the conjugate base will therefore decrease accordingly. Alright, so you subtract away minus 0.004. Okay, H plus is removed, and in this case your acid will increase because you form your acid in the process. So again, similarly, we did not give you any volume of the acid. We assume that it's going to be negligible change in volume. Right, again, negligible change in volume. So volume is still as 1 dm cubed. Given these values that we have, find the final value of your conjugate base and acid. Alright, given that the volume is more than 1 mole per dm cube, that will become the mole. Substitute into your acid buffer equation, pKa plus log salt over acid. Work out your new pH, 3.39. Okay, so compared to the original pH of the solution calculated in B was 3.43. So there's a 0.04 decrease. Okay, it's corresponding to what we understand. If you add in acid, the pH will have a slight decrease, right, for a buffer. Okay, that's it for your question 4D.